will discuss about the magnetic orbital quantum number. Magnetic quantum number, it is denoted by the ML, small letter m, subscript small letter L, and it gives the information about the spatial orientation of the orbital with respect to the standard set of coordinate axes. If you followed my previous class number 32 and 33, there I discuss the principal quantum number and azimuthal quantum number. Here I am discussing on the magnetic orbital quantum number ML. For any subshell, subshell means subshell is defined by the L value, that means azimuthal quantum number, and for any subshell there is the 2L plus 1 number of values of magnetic orbital quantum number, that means ML, are possible, and these values are given by the minus L. L means here the azimuthal quantum number, then minus L minus 1, minus L minus 2, and so on, and up to 0, 1, and so on up to L minus 2, L minus 1, and L. When we'll give the example for the number of the L, then this will be more clear. So case number 1, when the azimuthal quantum number L is equal to 0, then the only permitted value ML is equal to 0. Because 2L plus 1 L is equal to 0, that means the only one permitted value of ML, and then only one permitted value for the ML, then it is the 1s orbital. Case number 2, when L is equal to 1. So when L is equal to 1 in 2L plus 1, if you put the 1, then value is 3. That means the number of the value of ML will be 3 numbered. That means here in this case the 3 p orbitals, and its ML value can be minus 1, 0, and plus 1. As per, if you follow this, then you will know that minus L, that means when L is equal to 1, then minus 1, and then 0, and then plus 1. That means the from minus L it will be in increasing order. That means plus 1 we have to add, then it is 1 and plus 1. So these 3 numbers of p orbitals present when L, azimuthal quantum number, is equal to 1. Now case number 3, when L is equal to 2. L is equal to 2 means here the 2L plus 1, this value if you put 2, so 5 number ML value will come. That means 5d orbitals. And what is the value of this ML? ML is equal to minus 2, minus 1, 0, plus 1, plus 2. Minus 2, why it is minus 2? Because as per this value, ML is equal to minus L. That means when L is equal to 2, that means ML is minus 2, and increasing with unit. That means plus 1 you have to add, then it is the minus 1, again plus 1 you have to add, then it's 0, and then plus 1 if you add, then plus 1, and then again plus 1 if you add, it is the plus 2. Now what you have to remember, values of ML, as you know from the just last slide, that it derived from the L, and from the class number 33 you can see this value, that means this is the azimuthal quantum number L. This value of azimuthal quantum number again derived from the principal quantum number N. Principal quantum number is defined by the small letter n. Azimuthal quantum number is defined by the small letter L. You can understand very clearly if you follow the previous class number 32 and 33. Whatever we understood, that each orbital in an atom is defined by a set of values. Set of values, what is this? The principal quantum number N, azimuthal quantum number L, and magnetic quantum number ML. So each orbital is defined by these three numbers of values, N, L, and ML. So an orbital described by the quantum numbers, as for example, when N is equal to 2, then L is equal to 1 and ML is equal to 0, then this is the orbital in the p subshell of the second shell. Second shell, it is very clear because shell is defined by the principal quantum number. So N is equal to 2, that means second shell. If you follow, then see the value of the L when 0, 1, 2, 3, 4, 5, and accordingly the subshell notation already I discussed in the class number 33. And for the 0 value of L, it is the S subshell, and when the value of L is 1, then subshell is P, and when L is equal to 2, then the subshell is D, and when L is equal to 3, then the subshell notation is F. And if you see the number of orbitals, then for S subshell, only one orbital is present, and for the subshell P, the 3 orbitals are present. For subshell D, 5 orbitals are present in atom, and when the subshell notation is F, in that case the number of orbitals present in an atom is the 7. So it is very clear that when L is equal to 1, that means this one, that means it is the p orbital. That's why we have written this is the p subshell. Now, till now I discussed the magnetic quantum number. Now, another quantum number, electron spin, which is defined by the small s. Why it needs? What is the background of the discovery of the electron spin s? That we need to understand very clearly now. So these three quantum numbers, N, L, and ML, leveling the atomic orbitals, can be used equally well to define the energy and size. Energy and size for what? For the principal quantum number. And azimuthal quantum number L, what it defines the shape. And ML, magnetic quantum number, it defines the orientation. But all these quantum numbers are not enough to explain the line spectra observed. This is the experimental findings in case of multi-electron atoms, that some of the lines actually occur in doublets, that means 2 lines closely paced, and triplet, that means 3 lines closely paced. And this doublet and triplet cannot be explained by only these 3 quantum numbers, N, L, and ML. So in the year 1925, George Uhlenbeck and Samuel Goudsmit, sometimes we need to know that in every discovery, who is the scientist behind it. And they proposed the presence of the 4th quantum numbers known as electron spin quantum number, which is defined by the MS. An electron spins. What is this? Electron spin quantum number, that an electron we know spins around its own axis, much in a similar way as Earth spins around its own axis while revolving around the sun. So in other words, what we can tell, that an electron has beside charge and mass an intrinsic spin angular quantum number. That means electron not only has the charge and mass, it has the intrinsic spin angular quantum number. And that is why the doublet and triplet, that means very closely related energy levels in line spectra of multi-electron atomic system was found. So this spin angular momentum of the electron, it is a vector quantity. That means it has direction. And it has two orientations relative to the chosen axis. So these two orientations are distinguished by the spin quantum numbers ms, actually it is the m subscript s, which can take the values of plus half or minus half. And these are called the two spin states of the electron. That means spin quantum numbers, it is fixed. It has only two values, plus half or minus half. It is not dependent on the principal quantum number value, azimuthal quantum number value, or magnetic quantum number value. And here this is the spin up and spin down. In this way, we easily express the electron. These two electrons that have different ms value, that means one plus half and the other minus half, are said to have opposite spin. An orbital cannot hold more than two electrons. And these two electrons should have opposite spins. That means in an orbital, maximum two electrons can stay, and these two electrons should be in opposite spin. So now we'll sum up the whole four quantum numbers, what I described in my class number 32, 33, and 34. Now we'll sum up all four quantum numbers. Number one, principal quantum number n defines the shell, determines the size of the orbital, and also to a large extent the energy of the orbital. Number two, there are n numbers, that means principal quantum number n. So n numbers of shaft shell in the nth shell. It is possible, subshell. That means L, that means azimuthal quantum number L, identifies the shaft shell and determines the shape of the orbital. So there are 2L plus 1 number of orbitals of each type. I already discussed in a shaft shell. That is 1s orbital when L is equal to 0, 3p orbitals when L is equal to 1, and 5d orbitals when L is equal to 2 per subshell. I already explained it in the previous slides. To some extent, the value of azimuthal quantum L also determines the energy of the orbital in a multi-electron atom. Point number 3. The magnetic quantum number ML designates the orientation of the orbital. Just now, whatever I discussed. And for a given value of azimuthal quantum number L, then the magnetic quantum number ML has 2L plus 1 values and the same as the number of the orbitals per shaft shell. It means that the number of orbitals is equal to the number of ways in which they are oriented. Now, fourth point, spinning quantum number MS. It refers to the orientation of the spin of the electron. and two possibilities there. And ms value just now I discussed is the plus half and minus half.